So how to get the reduction of the stress traces and why you would want to do this? We would like to reduce this amount of the stress traces because it would reduce the risk of the fracture. Simple like that. So, design factors. Implants are designed to have optimal geometry with aim to avoid sharp surface discontinuity. Yes, I mean implants like the artificial hip joint, for example. Manufacturing aspect. Materials for implants are carefully selected in terms of fatigue tolerance and, where possible, for the treated to increase fatigue tolerance, for example, by lowering the amount of cracks on the surface, so polishing. Surgical techniques. Implants are handled and inserted with techniques to minimize surface scratches. One more time, because if there will be less scratches, there is less risk that these scratches would be a stress tracers and beginning of the fracture. So, what is the stress tracer? One more time. For example, that defect, like a screw pinhole in the bone, reduces in strength. There is a direct relation between the size of the defect and the reduction of bone strength. So, a hole that is 1/3 of the diameter reduces bone strength by 50%. And generally, the smaller the defect, the smaller the influence it is. Okay. When we have also the sharp change in the cross-sectional stiffness at the junction of the end of the prosthesis and the bone, it's also the stress tracer. Yes, so it's hard to avoid these stress tracers, but if possible, of course, it's a good idea. So, what are the open section defects? These defects are longer than the bone's diameter, for example, bone window for infection or biopsy, and also dramatically reduce the bone strength. Yes? So, it's far easier to fracture such bone. Fatigue life. A fatigue fracture always starts as a stress tracer. Yes, it's true both for bone and other. Okay, and generally fatigue life of a structure can be far increased by reducing the number and size of stress traces. So these are some ideas. Yes, the best idea I see to understand the stress traces is just to get it by those lines. So those lines are showing the forces that are getting from top to down. Of course, this is not the only idea how the forces can be applied, but here it's very useful. And now look here. Yes, here this force cannot get down, yes, straight down. It cannot. Here it could, here cannot. Why? Because there is some hole in it. So this hole completely changes how the forces are applied in this structure. This force needs to get around, but this force needs also to get next to it, and this is next to it. So in this area we have far increased the stress. Yes, we concentrated the stresses in one point. The same idea is here. Here we could get straight down, here we can't. So we get around, here we get in incorrect line. So here we accumulated the stress. And here one more time, look. These lines are getting close to each other in this point. Here it is not so much. So when those lines are very close together, this leads to big problems because it increases the stress in this point. So one way of reducing the stress is by doing the smooth transitions. Yes. So this also shows it nicely. Yes. So in this area and in this area we have far increased the stress. Okay, thank you very much.